coming to my talk. It's a pleasure for me to be part of the speakers of Appium conference this year. It's a great opportunity to share something we've been working on lately. Since desktop automation has seen little to no innovation in the recent years, we're here to attempt to revive it with our new driver for Appium, which we called NovaWindows Driver. I'm really excited since it's not only my first time speaking at Appium conference, but at any conference in general. So I'll start with a few words about me. My name is Teodor. I'm from Bulgaria, and I work as a software developer in test that automates the planet. We're a company that builds scalable test automation solutions and offers professional services like consulting, mentoring, and training to make the testing and QA process smoother. Outside of work, I like to travel and meet new people. So I've been hitchhiking for more than 10 years now. And recently I've been really into couchsurfing. For those who don't know what couchsurfing is, it's basically like hitchhiking, but instead of getting a ride, you get to sleep on someone else's couch in some other country. And since I cannot contribute to the hitchhiker community since I don't have a driver's license, I have hosted many people at my couch in Bulgaria. And I have met people from all over the world, including from Valencia. I usually invite anyone to my couch who visits Bulgaria, but currently I'm in the process of moving, so these are my friends helping me move my couch. And yeah, let's start with what we're going to talk about today. I'm going to start with to set the stage about the desktop automation for those who are not very familiar with it. After that, I'm going to present and discuss the problems we had with the current Appium solutions for desktop automation. And after that, I'll introduce the new driver that we created and show its improvements in key areas. After that, I'm going to talk a little bit about how we made all this work. And then I'll quickly show you how to use NovaWindows Driver, and I hope we have time for questions. So yeah, let's start with the first thing, desktop automation. The desktop automation itself has seen a little bit of a decline in the last couple of years since more and more apps are moving towards web-based solutions like Electron. But still, some companies with heavy investments into legacy software or some specialized tools are still using the desktop automation, so it's essential for them. Last year, we were contracted by a company to automate their desktop app, some end-to-end tests. So we run a poll in LinkedIn to check what other companies are using for web automation. And Appium is still one of the most used tools, which was great since we already had it implemented in our open source test automation framework that we use in our company. And we already have expertise in some mobile testing. Yeah, we started automating with Appium. One of the problems we faced, actually no, let's talk about Appium a little bit. What Appium currently offers is Appium Windows Driver, which is basically just an interface for Windows App Driver, which by itself is closed source and hasn't seen any updates since 2021, and still has more than 1,000 unresolved issues. It's basically just abandoned, and Appium tries to fix this with some custom commands, but they're nearly not enough since most of the commands are carried out through WinAppDriver, which itself is very slow. We were automating end-to-end tests, and the more steps we added, the slower the automation has become, to the point where automation wouldn't have been viable for the actual application, since the company had a very fast release cycle. And other things that Windows WinAppDriver has, other issues, is scrolling to elements. It's not as straightforward as in WebDriver. You have to manually send a command to move your mouse and then scroll with that many pixels, which may be flaky on different resolutions or different DPIs. And one big problem that we faced was some elements were just missing from the elementary of WinAppDriver. What do I mean by that? Let's say we had a grid something like this, and let's say we had to input the product name based on the SKU. Sounds straightforward, although when opened through Appium, only these rows were visible in the element tree, and these were basically non-existent, nowhere to interact with them, nowhere to take the data. As we were debugging, we figured out in the inspect window, there are three views: row view, control view, and content view. And WinAppDriver is designed such that you can see elements only until the control view, and row view elements were just invisible for it. Other things that I mentioned is scrolling. As you can see, the tabs on this grid are, some of them are out of view. On different resolutions, even more of them could be out of view. And the only way to scroll to the tabs that are not visible is either to click on those arrow keys on the right, or to position your cursor somewhere in the tabs and send a scroll command for like 100 pixels or something like that, which is not very reliable. And also for the grid. So yeah, it's not really straightforward as in WebDriver. And also there's no programmatic way to interact with an element. Like, let's say we want to open the roles tab or permissions. What Windows Driver does is it moves the cursor on the tab and clicks, which sometimes would fail to click, and it would fail the whole test. And imagine our test was running for more than 20 minutes. It fails on the 15 minutes for that reason, and you have to start it over because there's no way to continue from the same place. Or you have to do some workarounds with checks if it actually clicked for each action. And yeah, it led to our tests being flaky. Other issues that we had, as I mentioned, was slow execution. Probably everyone who has automated Windows knows that the execution of tests in WinAppDriver could be slow, especially for XPath locators. Other thing that was slowing us down as well was text input, as it slowly sends the keystrokes. And this combined with the XPath locators, since we were just contractor to the company, we did not have direct relations to the developer team, and most of the elements did not have automation IDs. So we had to improvise with some XPath locators, like on the left of this label, there's a field. One thing, after we sent the proof of concept, there was one thing that they sent us a very weird error, something like that. Since the software that we were automating was in France, and the developers were using French keyboard layout. Turns out in Windows WinAppDriver, when you send text to a field, it actually sends actual keystrokes. And the French keyboard layout uses AZERTY, not QWERTY. And it just swaps those keys. They had to manually change it to English each time before they run the test, and then switch it back, which was a very tedious task, since sometimes they forget, and on the 15-minute the test fails. And yeah, other things that, like almost every task in WinAppDriver is slow, even clicking. This is an example of how fast Windows WinAppDriver can click. All the elements are found before the actual clicking, so this is only the clicking after the elements are already found. It has some hard-coded wait, which cannot really be configured in WinAppDriver. So in order to work around those problems, we had to execute some PowerShell scripts that were inputting the text in some other way. And yeah, the whole code got littered with PowerShell scripts. So at one point, I decided, instead of just executing PowerShell, why not create an Appium driver that does the same thing, but I can just use the native commands. So I'm here to introduce the NovaWindows Driver that we created. I'm going to start with the most simple task, the clicking. This is the same example with clicking, but this is the speed that NovaWindows Driver is executing it compared to WinAppDriver. They're both running the same code. The only difference is the automation name. For one is NovaWindows, for other one is Windows. And this is the time it takes for both of them to start the driver, find all the elements, click on them, and then close the driver. Other field where we improved was the text input. This is the speed that we achieved with NovaWindows Driver. We tried to do it faster, but sometimes it was skipping some keys. So this was the fastest and reliable way to input text. This is again running the same code for both of them. But in order to keep compatibility, since we had already developed most of the tests in Appium, we didn't want to rewrite everything, and this method of inputting also sends keystrokes. So this does not really solve the keyboard layout issue, since if we make it send Unicode characters, some shortcuts like Control-C, Control-V, or anything else that we use with keyboard with key combinations wouldn't work. So in order to solve this, we had to implement some custom commands. One of them was set value, which is used like this, and that directly sets the value into the text in input field. This does not only solve the issue with the text input with different keyboard layouts, but also significantly improves the performance. This is the example from before, and the right one is with the custom commands. This is not the only command that we implemented. Actually, we implemented a bunch of commands that directly interact with the element. For example, invoke instead of clicking. You don't have to have the element in view if you're not testing this specific path for the UI. You just want to invoke some operations and test if the actual function works. And expand and collapse for a lot of drop-downs. Select for the tabs that I mentioned before. And we don't really use them raw like that. We actually have implemented them in our open source framework. So we just have the actual methods that are that implement and use all those commands. So in the end, you just get this thing like select by test, and it just works a lot faster than with WinAppDriver. Again, to ensure compatibility, we have implemented most of the commands from Appium Windows Driver. There are some that are yet to be implemented. We just didn't need to use them for the project that we were working on. So this work just out of the box. You don't have to change anything in your code. And let's talk about XPath element finding. The way I have observed that WinAppDriver finds elements is, let's say, the things that it does. It starts from the root, which is usually with the window of the application. It looks for all all its children, and then recursively looks for all its children, and so forth. And which with each step gets more complicated, and for more complicated UIs, it takes a lot more time. Then it converts it to an XML, which you can't really see well here, but it's just an XML. But you can't really find anything by this tree, since usually you look for some properties like automation ID or class name or whatever it is. So for each element, it also has to find all the properties, which takes a lot more time. And it uses some internal parser to parse the XPath and find the element and return it by its runtime ID. And it does this for every XPath query executed. This structure is actually of the calculator app, so you can imagine how complicated it could be for apps with more complicated UIs. The way our driver handles this is, let's say we have this XPath query. It separates it into different steps, and then looks for all the meaningful elements. In technical terms, tokenizes it, and starts from the top. It starts from the root and finds all the descendants with this class name. And then from the result, or results, in our case only one result, it looks for the descendant button elements with this automation ID. And from it, it looks for an ancestor, or ancestors, depending if you're looking for one or many elements, with this type. So we narrowed all this down to 3 operations, as opposed to 12 operations, and taking all the properties of each element, which made them significantly faster in our case. Although there are still some XPaths that could be executed slower with our approach, since under the hood, Windows UI Automation Accessibility Library can check only for equality for properties. This XPath would run a lot slower, since we're checking if the class name contains this string. So it will start from the root. It will look for all the descendant elements, and it will for each them until it finds an element with that the class name contains the string, and then it will return the element. But it will still be faster than looking for all the elements and all their properties. Next thing I'm going to talk about is, let's say we have this calculator app, and we want to verify that the image of the calculator icon is on the left of the calculator string in the title bar. If we open the inspect tool, we noticed in control view the calculator icon is not visible as an element. Therefore, we can neither get it nor interact with it in WinAppDriver. Only we see it if we go to row view. So in order to ensure compatibility and that the element trees are the same between WinAppDriver and our driver, we put control view as the default option, since it's not really a common problem, and you use it only if needed. And the less elements you have, the faster it will be for elements to be found. So how do we actually enable that in our driver? From the platform specific commands, we had this one called push cache request. Why exactly that name? Under the hood, how we enable the row view elements in Windows UI automation is we create a cache request, and we set the tree filter to row view condition, and then we push it. Hence the push cache request name. So how do we do that actually in our driver? We just create some JSON-like structure with tree filter, and the filter that we actually want to apply. We can see all those filters in Microsoft's website about UI automation. If you want to build some custom filters, let's say we are only going to interact with buttons, so we expose only the buttons, which would significantly improve the element finding as well. And in order to not write the namespace or condition every time, we can also shorten it to just row view in this case. And yeah, it's time for the scary part. I'm going to try to do a live demo. Not here. So yeah, over here I have just ripped the code of one of the samples from WinAppDriver about automating the calculator app. I have just translated it to Appium, not a lot of changes, especially in the tests. Everything is the same. So first I'm going to run the automation, all the tests with WinAppDriver, and show you the performance. So yeah, this is just finding the elements and clicking on them. Nothing special is done. Also asserting everything. This is the fastest it can get with WinAppDriver. So the only change we have to make is changes to NovaWindows Driver. And let's observe the performance again of the same test. Yeah, not sure why it's clicking on the site right now. I think because the resolution changed. So yeah, this is the time it takes for the whole test to execute. And one problem with the actual moving of the mouse and clicking, currently you don't see my, my cursor actually moving because it's in a virtual machine. That's why I have enabled this red thing to show where the cursor is. So imagine you're running a test on your machine and you accidentally move your cursor a little bit. This would cause all the clicks and everything to fail to click on the right location, which would fail all the tests. So this one with the same test, but with, let's say, invoke instead of click, would directly interact with the UI elements. So you can, while running the test, you can move your mouse, you can move the calculator, you can try to fail the test somehow, and it will always click on everything properly. And yeah, except if you minimize it, then all the elements will just disappear. But yeah, it also improves the performance. So the whole test run in less than 4 seconds. And with WinAppDriver, it took about 16 seconds, I believe, last time I checked it. So yeah, let's talk a little bit about the technical side. How Appium drivers usually work, how the Windows Appium driver works, is when you create a session, it actually spawns a WinAppDriver process, and it just uses the Appium driver as a proxy to send the commands to it. Which was actually sometimes failing to make the connection, and it was just randomly failing some tests. We were also looking for a solution that would not require a prior setup of the machine. We wanted to use something that was already available. That's why we opted out for the PowerShell, since it's available on every Windows machine. And the way our driver works is it spawns, starts a PowerShell process, a PowerShell session, which is then we send to it some initial commands to set up, like to include the UI automation client library and all. And then it uses UI automation commands throughout the whole thing. It uses one session for the whole driver, so it does not put separate process for each command, which also improves the performance of our previous approach to sending PowerShell commands, which each command spawns a different isolated PowerShell session. A little bit about the UI automation commands. They're part of the Microsoft's UI automation accessibility library, which exposes most of the UI elements and unifies the name of the properties between different frameworks like Win32, WPF, WinForms, UWP, and usually more can be implemented for the apps. For some commands that can be carried out with the UI automation library, we use foreign function interface library, Coffee, which is actually used in the Appium Windows Driver as well to carry out some operations for those platform-specific extensions. This is how we use it. It calls the user32 DLL of functions, and yeah, that's basically it. About the whole driver is written in type-safe TypeScript, and how to use our driver. In order to use it, as all Appium drivers are written in Node.js and JavaScript, you have to have Node.js installed, and then you have to obviously install Appium. If you're coming from pure WinAppDriver, you have to translate some commands to Appium, which should be quite straightforward since most of them are really similar. If you're coming from Appium Windows Driver, the only thing you have to change is change your Windows driver. So you can clone our repo. You go to that directory and run an npm run build, since the driver is written in TypeScript. It has to build it in pure JavaScript in order to be used. And in order to just run it without installing it, you can actually just run the Appium command in the directory, and it will directly start Appium session with only this driver installed. Note that this way will not allow you to use different Appium drivers. And in order to install it, since currently we don't have it in npm, you can run Appium driver install source local and path to the repo, but you have to do it from a different directory, since if you run Appium in the directory, it will recognize it as already installed. And yeah, that's basically it, if you have any questions. Thank you.
Thanks, Theo. I'll kick off the questions, actually. This is great. Thank you for doing this. First question is, when are you going to publish it on NPM?
We're trying to stabilize it, and we have to write a couple of tests in order to ensure that we don't break something with every change that we make. It's still in a very early stages, but we have already successfully applied it in production. So yeah, we have to ensure that every version we publish that doesn't break something before that. Our goal is to also implement the tests from WinAppDriver. And yeah.
Great. Last question for me. I don't know much about Windows automation, but I've heard there's this thing called FLA UI. I'm not sure how you pronounce it. I'm wondering what the technical difference is between those approaches.
They're both using the same thing in the backend. Technically, behind the scenes, they work the same way. Our way does not require some third-party driver to be installed. It just uses PowerShell, which lowers the prerequisites that you have to do as a setup on each new machine. And FLA UI also had some hard-coded weights for the clicks. It is open source. You can remove them, but I don't think it still has a full-featured Appium driver. It has some experimental driver that we tested after that, but it uses the precompiled binary. And yeah, that's basically it.
Fantastic. Questions from anyone else?
Hello. Thank you for the presentation. It was very nice to find a new alternative to the WinAppDriver. Yeah. I was wondering if this new driver will be distributed also as a nugget, you know, for
as
those.
For C#, you can just use the regular way you use Appium. The only thing you have to change is change the automation name from Windows to NovaWindows. No other changes required.
Okay, thank you.
Well, all right. Ooh, you're all the way over there.
Thank you. Thank you for the talk. It was very interesting. I was wondering if by using the PowerShell, are you bypassing any events on Windows, like clicking events or switching windows, stuff like, you know, in comparison when you're using JavaScript on web browsers instead of interacting the elements?
Yeah, so for the clicking of the elements, we actually use the low-level API to move the mouse and click on the elements. So in order to bypass the clicking events, you have to use those platform-specific extensions like Windows Invoke. So the default click is actually clicking the same way it clicks on a WinAppDriver.
And other elements?
Like
entering text?
Yes, entering text. I think we used the WinForms send keys command, so it sends the keys the same way it does.
Great, thank you very much.
No problem, thank you.
Sorry. More questions, we've got time.
Over here.
Oh, Dan. dangerous.
Oh no, this is a simple question. Does it work with web content and hybrid apps?
Not really, not well. We're planning to use C# as a backend to improve the compatibility with Windows with web elements, because currently it does not work real well with Chrome-based apps. Maybe a little bit better than the current version of this one, but still it's better to use like Selenium WebDriver for them at this point.
This is great. I'm really excited about this. We've been using WinAppDriver for years, and it is awful, so I'm really excited to try this out. Have you seen any issues with like lock screens? That's one of the things that we
with what? I didn't
lock screens, like Windows lock screens.
We have not tested this thing for the lock screens.
Okay.
On my way.
Hello, thank you very much for this very interesting talk. I'm curious, what if an element doesn't have an auto ID? How do you configure the element to have an auto ID?
Well, that's up to the developers to implement the auto ID, and we worked around the elements that didn't have auto ID. We used XPath locators to locate the actual elements, which were very slow in WinAppDriver. That's why we implemented this improved way of finding elements by XPath.
Cool, thank you very much.
Problem.
Okay, last comment for me. You're probably familiar with this issue on the WinAppDriver repo that is, thousands of posts long. People asking, why doesn't it work? Why doesn't it work? Mm-hmm. You probably know the one I'm talking about. Have you gone and posted about NovaWindows Driver in that thread yet?
No, this is the first time talking publicly about the
wow.
driver. We pushed the repo, I think, 1 or 2 days ago.
Wow, well, that's very special for all of us. And yeah, definitely go post it there, because you'll get a lot of very interested users very quickly, I imagine. All right, everyone, give another round of applause for Teo. Thank you.
Thank you.